Greetings and welcome to a channel that seeks to reveal a much grander version of what we are, according to the laws of physics. In this episode, we'll continue to catch up on what's missing from our high school education when it comes to our understanding of what we are. I think you'll be quite surprised at the current mainstream consensus regarding what we are made of. What we are made of is the subject of an excellent lecture by David Tong, Professor of Theoretical Physics at Cambridge University.
Tonight, I'd like to tell you about one of the big questions in science. And the question is simply this. It's, what are we made of? What are the fundamental building blocks of nature that you and me and everything else in the universe are constructed from?
At school, we are taught that the fundamental building blocks of the universe are particles. However, there is a problem with this picture, according to Professor Tong.
The problem is, it's a lie. It's a white lie. It's a white lie that we tell our children because, we don't want to expose them to the difficult and horrible truth too early on. It makes it easier to learn if you believe that these particles are the fundamental building blocks of the universe. But it's simply not true.
This picture being referred to is based on the planetary model of the atom, which is a teaching aid that is modeled on physics as it was about 100 years ago. Modern physics teaches a different model of the atom called the quantum model, as discussed in my previous video. The quantum model suggests we are made of atoms depicted like this. This is a hydrogen atom, which in the familiar planetary model would be depicted like this. It has one electron, one proton, and no neutrons. However, in the quantum model, this single electron is depicted as an electron cloud. This electron cloud is best explained using the double-slit experiment we discussed previously. The electron cloud in the quantum model is the same uncertain, undefined cloud that we see here before the electron hits the detector screen. We previously saw how strange and confusing the electron's behavior was in this experiment. And now we can see that the strangeness and confusion is baked into the definition of the atom. One of the early mysteries of quantum mechanics was the question of whether a particle of matter is a particle or a wave. In other words, is it a tiny solid ball, as depicted in school physics, or is it a wave in the same sense that light is a wave, without any solid component at all? Initially, it was thought to be a combination of both, but it later became clear that particles of matter are entirely waves. Let's rejoin David Tong as he describes the electron.
So there is spread everywhere throughout this room something that we call the electron field. Okay, it's like a fluid that fills this room and in fact fills the entire universe. And the ripples of this electron fluid, the ripples of the waves of this fluid, get tied into little bundles of energy by the rules of quantum mechanics. And those bundles of energy are what we call the particle, the electron.
So, according to Professor Tong, there is an electron field, which is a fluid-like substance spread out throughout the entire universe. And an electron is ripples in this electron field, tied up into a little bundle of energy. The shape and nature of these ripples is not yet known, so for now, physicists generally make use of the idea of a point particle. A particle which is an infinitesimally small point, which is ideal for mathematical calculations, but not ideal for people drawing diagrams such as myself. There is no conventional way of depicting a particle, but I prefer this picture because it clearly shows the wave-only nature of particles. This wave nature must be centered around a point, and in a later episode I will discuss these point-centric waves. So now we have met the electron field, but is there also a proton field and a neutron field? No. Fields only exist for elementary particles, or particles without a substructure. Protons and neutrons are not elementary. In modern physics, they have a substructure, which was discovered in the 1970s. A proton comprises 2 up quarks and a down quark, while a neutron comprises 2 down quarks and an up quark. Up quarks and down quarks are regarded as elementary particles, so there is also spread throughout the universe an up quark field from which up quarks are formed, as well as a down quark field from which down quarks are formed. So now we can see that when we drill down to the most microscopic levels of physical matter, we find that there is nothing solid anywhere in our world. Everything we call solid is nothing more than ripples in quantum fields. It's somewhat misleading, therefore, that the word particles is still used in physics, as well as the image of a solid ball. Some physicists have suggested that the word wavicles be used, because, as David Tong says,
there are no particles in the world.
Now, you may be wondering, if we are all made from waves, why is it that we can't put our hand through somebody's chest, like Brian Greene is doing here? Up until now, you most likely assumed that you feel solid because you're made from solid particles, as you were taught in school. However, we now know that particles are not solid, and it is in fact electric charge that gives objects a solid feel. A proton has a positive charge, and an electron has a negative charge. Opposite charges attract, and like charges repel, in the same sort of way as the poles of a magnet. The outermost part of your hands comprises the electrons of the atoms on the surface of your skin. So when you clap your hands together, you are bringing together like charges, and like charges repel. Now let's move on to the question of light. According to school physics, light is an electromagnetic wave that travels along like this. According to modern physics, however, light consists of particles called photons. So a beam of light is actually a stream of photons, which when plotted on a graph have the same effect as the school physics wave. Since a photon is an elementary particle, it also has an associated universe-wide field called the electromagnetic field. Like matter particles, it also has unknown shape. So I will also use the same point-centric image I used for matter particles, since they are all represented by the concept of a point particle. Now let's move on to the question of empty space. The universe is mostly empty space. So what is it?
Take a box and take every single thing that exists out of that box. Take all the particles out the box, all the atoms out the box. What you're left with is a pure vacuum, and this is what the vacuum looks like. It's a computer simulation of absolutely nothing. This is empty space. Literally empty space with nothing in it. This is the simplest thing you could possibly imagine in the universe. And you can see it's an interesting place to be, empty space. It's not dull and boring. What you're looking at here is that even when the particles are taken out, the field still exists. The field is there, but what's more, the field is governed by the rules of quantum mechanics. And there's a principle in quantum mechanics, which is called the Heisenberg uncertainty principle, which says you're not allowed to sit still. And the field has to obey this. So even when there's nothing else there, the field is constantly bubbling and fluctuating in what's, quite honestly, a very complicated way.
So if we were to zoom in on a block of empty space, we would find the electron field rippling in a complicated way. In the same space, we would also find the up quark field, the down quark field, and the electromagnetic field, all constantly rippling. These fluid-like fields are all interconnected, so you could say they form an ocean of interconnected fluid-like fields, which I will depict with this purplish color. This ocean of fields actually comprises more fields than just the 4 I have mentioned. There is a field for each type of particle in the standard model of elementary particles. However, I have only discussed these 4 in order to keep things simple. These are the four particles most relevant to our day-to-day living, since they form the matter and light we perceive in our world. So now we can see that the universe is a single object. It's one ocean of interconnected fluid-like fields. Everything in the universe is formed from ripples in these fields, including you and me and so-called empty space. Empty space is where the ocean is rippling with lowest energy. You and I are places where the ocean is rippling with higher energy, and in a more structured way, if you can imagine these waves tied up into little bundles of energy, like little whirlpools in the ocean. So you and I are actually interconnected, since we are part of the same ocean.
We're all connected to each other. It's like, the waves on the ocean all belong to the same underlying ocean. The electrons in your body are the ripples of the same field as the electrons in my body.
Now let's get back to the original question. What are the fundamental building blocks of the universe? Or what are we made of? According to mainstream physics, the fundamental building blocks of everything are not these waves that we still call particles. It's not these ripples in various different fields, but it's the fields themselves that are fundamental. In the same way that you wouldn't say the ocean was made of waves, you would say it's made of water. Now that we've established that the universe could be regarded as a single object, or a single ocean of fields, this allows us to ask the question, are we alone in a whole new light? And by that I mean, could there be other dimensional realities in which intelligent life exists? I don't see how that could be possible if the universe was a bunch of separate objects. But if the universe is a single ocean of fields, then new possibilities open up, as I will show in later episodes. This is where sideline science has so much to say. And once again, parapsychological experiments could open the floodgates to the new physics that would explain other dimensional realities, as I will discuss in my next video.